Okay, let me switch to share screen. Share screen. And should be this screen. You see the share screen?
Yes. Yep.
Okay. Again, today talk about the day dinosaurs died. So we assume that we know that dinosaurs have been living with us for over 100 million years. They were dominant creatures on Earth at that time until a asteroids killed them all, and because they died, and therefore all the ecological niche is now released, and mammals started to become dominant, and we are mammal anyway. So the next one will be about how mammals seize the date and becomes dominant. But before that, we need to know why the dinosaur died. This will be a little bit shorter video. After that, we will have discussion. Okay, let's go.
Picture a world of giant reptiles, flying pterosaurs with 40-foot wingspans, while beneath the waves, fierce predators called mosasaurs prowled the seas, and dinosaurs roamed the land. For more than 100 million years, creatures like these ruled the planet. And then they were gone, lost in the shadows of time. Their extinction, a mystery for the ages. This is all we have left of those magnificent creatures. Bones. And a lot of them. We've collected enormous numbers of bones, and from them we can tell how these creatures lived, what they looked like, when they lived, but we don't know why they disappeared. To solve that mystery required some of the greatest scientific detective work ever, and the trail began almost halfway around the world from here. This is Gubbio, a sleepy Italian town. Not a single giant reptile in sight. Still, the past is everywhere you look. In the medieval palaces and churches, the homes and narrow streets, while an even deeper past lies nearby. Just outside of Gubbio, Alessandro Montanari is looking for that distant past. He's a time traveler, moving towards the lost world of the dinosaurs. Its ancient history written in these limestone cliffs.
Millions of years ago, these mountains were at the bottom of a deep sea, collecting layers of sediments deposited slowly through time and eventually pushed by tectonic forces, folded and uplifted.
So, all of this rock and all of these layers were once at the bottom of the ocean.
Exactly.
And then all these other forces have brought this old rock up to you.
Yes, that we can actually study layer by layer, like pages of a book, the history of the Earth.
Gubbio's deep sea limestone, now exposed by the side of the road, became a magnet for scientists. Especially this site, that may seem ordinary, but holds one of the strangest features to confront a geologist. A thin layer of dark clay. In the 1970s, the clay captured the attention of an American geologist, Walter Alvarez. He He was trying to determine the relative ages of the limestone layers by analyzing the fossils left by tiny shelled sea creatures. Called foraminifera, or forams for short, they're among the most common ocean plankton. When they die, their shells become part of the sediment. Since many different species have evolved over the ages, they can serve as markers of geologic time. But as Alvarez studied them, he noticed something striking.
Well, what he sees and was puzzled by, after the very top of that white layer, all these very diverse microfossil species would disappear. Okay.
So, Sandro, when Walter Alvarez looked in these rocks, he saw all these species of forams.
Yeah.
They're plentiful. There are many species for thousands and thousands and thousands of years. But after this little seam of clay here, all the way up through these rock layers, those forams are missing.
Those species are gone.
Disappeared.
Disappear.
And that's a fundamental mystery. What would make these little creatures disappear?
Yes.
So Alvarez was stumped. What did this thin line of clay represent? It was laid down 65 million years ago, the same time when the dinosaurs disappeared. Was there any link? The same questions were being asked 1,500 kilometers away in Spain. On the Atlantic coast, outside the town of Zumaya, Dutch geologist Jan Smit was studying the forams from a different ancient sea. Their fossilized shells formed these limestone rocks, which, like Gubbio's mountains, were once at the bottom of the ocean. Now exposed, they represent over 1 million years of a geological time period known as the Cretaceous. Like Alvarez in Italy, Smit had also found a strange clay layer formed at the same time, which told a dramatic story. Jan, what can we tell about Earth's history from just looking at these rocks?
Well, you can see the end of the one world and the beginning of the next one. And you see there is a very sharp, extremely sharp dividing line between the two.
That gray band.
That's that gray band over there. At the bottom of that gray band, you see it's razor sharp.
And this reddish maroon rock, the oceans are healthy and steaming
They're
along just
healthy,
fine.
they're steady, they don't change at all. And all of a sudden we see a dramatic change, which we call the KT boundary.
The KT boundary, found at the bottom of this gray layer, marks not only the end of a period, the Cretaceous, but also of the Mesozoic era, a much longer stretch of time. The history of animal life on Earth has been divided into 3 such eras. Early life, or Paleozoic, the age of dinosaurs, or Mesozoic, and the era of mammals, or Cenozoic. The Cretaceous Tertiary boundary lies right in between these 2 eras, marked here by this layer of clay. What drew you to this boundary, Jan?
Well, Sean, we're looking here at the very topmost rocks of the Cretaceous. These rocks are literally packed with foraminifera. So we call this the Cretaceous, and these rocks here are the Tertiary. And the base of the Tertiary consists of a dark gray clay layer. And there, the life has almost disappeared. And the KT boundary is just in between. I can point at it. It's right here, where you see a contrast between the purple and the dark. It's an extremely sharp boundary.
And just across that thin little boundary, there's this huge change in what you see in the forams. And why is that so stunning to you?
It's so stunning because there is no preceding evidence of anything happening there. So it doesn't matter if I take a piece here, a piece there, or just underneath what we call the KT boundary. The foraminifera will remain the same, so they don't change overnight. And then, bang, they're gone.
So what's that tell you?
That tells me the base of the food chain of the oceans disappeared. And everything which is dependent on it is totally zapped right at the boundary.
In Amsterdam, the change at the boundary becomes clearer when Smit takes a closer look at the evidence. In his lab, he analyzes forams extracted from the limestone. Under the microscope, the rich diversity of fossilized shells from the Cretaceous snaps into focus. Some 4 dozen species appear below the boundary. But above it, there's a different world.
And these are the foraminifera from just below the boundary. And these are from just above the boundary.
Only a few species have survived into the tertiary, and they're much smaller.
As soon as you see that extinction and you realize at the same time that the dinosaurs are disappearing, you know you're looking at something very important. But you see it and nobody has witnessed it. So we're looking for silent witnesses in the rock, and the first thing that comes to mind is this beautiful clay layer.
A layer varying in color and thickness and found around the world. Walter Alvarez also believed it was a silent witness to the end of an era. The key question was, how long did it take to form, for the world to change? To find out, he sought help at the University of California at Berkeley from a Nobel Prize-winning physicist. Someone he knew pretty well, his father, Louis Alvarez. Louis loved a good mystery, no matter what field it was in. And that's how physics joined geology in the quest to explain the KT extinction.
Alvarez looked at this layer, tried to figure out how he could determine the time scale. He brought in his knowledge of astrophysics, his knowledge of nuclear physics, and realized that there's an element that's relatively rare in the crust of the Earth that occurs in meteorites.
The element was iridium, which falls steadily in an invisible rain of cosmic space dust. If the layer had taken thousands of years to form, Alvarez thought there might be just enough iridium to measure. But when the clay was tested, scientists were stunned to find it contained 30 times more iridium than the surrounding rock. Moreover, samples from other KT sites had similar levels, too much to come from ordinary space dust. What could explain so much iridium deposited around the world? Perhaps a catastrophic event in outer space. Alvarez wondered if a supernova exploding nearby might be responsible.
So he asked me if that was possible. And I concluded that there was only one chance in a billion that such a supernova would occur that close in 100 million years.
A supernova would have also deposited a rare isotope, plutonium-244. But testing revealed there wasn't any.
Well, I suggested, alternatively, that it could have been an asteroid or a comet.
There are hundreds of asteroids whose paths cross the Earth's orbit. Their sizes range from a few meters to hundreds of kilometers across.
So Louis Alvarez had this hypothesis that an asteroid or comet would cause this destruction. He had the clue, the amount of iridium at Gubbio. Under this hypothesis, it would be spread all around the world. So now he could calculate how much iridium there had been laid down over the entire Earth. Now, he also knew how much iridium there is in asteroids and comets, so he can now calculate the size of the object.
The answer was sobering. An asteroid 10 kilometers in diameter, as large as Mount Everest, and weighing hundreds of billions of tons. Still, how could something that size wreak havoc on a large planet? Because traveling through the vacuum of space, it would have slammed into the Earth's atmosphere at 80,000 kilometers per hour, 20 times faster than a bullet, heating the air to several times the temperature of the sun. At impact, the energy released would be equal to about 100 million nuclear bombs exploding at once. A huge mass of pulverized debris would have been blasted into space, some of it orbiting the Earth before raining back down. The debris may have blocked out the sun for months. Photosynthesis would have stopped. Plants, plant eaters, and then meat eaters would have died. This was the asteroid impact hypothesis for how the Mesozoic era ended. A big idea that was just too big for some.
When the Alvarez hypothesis was first proposed, it was difficult for many scientists to accept because for almost 2 centuries, geologists had crafted their worldview around a gradual picture of slow but steady change in the Earth without major catastrophes. Now, they were hearing a proposal that something had come from outer space and rewritten the history of life in almost an instant.
Louis Alvarez got very frustrated when the paleontologists didn't say, "Yes, sir, thank you for solving our problem." But many of the paleontologists just looked on him as someone who didn't know their field and was stepping into this just because it was such a big, important, famous problem.
The controversy would continue for years. To convince the skeptics, more evidence was needed. One criticism of the KT hypothesis was the lack of a crater the right age, type, and size. Alvarez thought it should be 200 kilometers across, bigger than the state of Connecticut. How could you miss that?
They looked for craters that were 65 million years old all over the Earth. Many of these things had been discovered and had been measured. Didn't find any.
2/3 of the planet is covered by water. If the asteroid landed in the ocean, the crater might never be found. Even so, there would still be a trail of debris, ejecta blasted from the crater. So attention focused on finding this evidence. Geologist Jan Smit discovered glass-like beads in KT boundaries called spherules, formed when vaporized rock cools and rains back down. Another key clue was rock that had been so shocked by the impact, it had crisscrossing bands of dislocated minerals. This was shocked quartz.
And we know if you set off a nuclear bomb, the damage done to the surrounding rocks will produce you a shock quartz. So if you put 2 and 2 together, we find shock quartz at the KT boundary and shock quartz in nuclear craters. You know it is an explosion which deforms your quartz crystals. And quartz is only found on land. So that was the big clue. We have to look for a crater somewhere on land.
The search for fresh clues led here to Texas, along the Brazos River, some 300 kilometers from the Gulf of Mexico. 65 million years ago, this was the bottom of the sea instead of grazing land. In the early 1980s, scientists noted unusual deposits of sediments across the river basin. Intrigued, Alan Hildebrand, then a graduate student in geology, came to investigate.
It's actually easy with fresh tracks.
Along the banks of the river and its tributaries, he examined exposures of the KT boundary different from those seen elsewhere, and saw something on top of the Cretaceous mud and rock that had once accumulated on the sea floor.
So this is the typical mud just found in this area?
Exactly. All we see is this gray Cretaceous mud. And there's 7 million years of this mud here. So, I mean, we're talking boring.
Right.
You know, there was nothing going on. But see, right here, the seafloor has been eroded right at this point.
An untrained eye might see this sediment and never look twice at the protruding boulders. But Hildebrand saw evidence of a catastrophic event.
So something happened here. It eroded the seafloor. And we start seeing these very coarse sediments. And this first unit is really quite extraordinary because if you trace round over here, you see, here's a boulder in it that's like 50 centimeters across. And you come over here, this is another one. It was weak, so it's weathered out, but it's even bigger. Here's another boulder, but notice this boulder is different stuff than these.
So you had this really regular mud layer, and then all of a sudden this area that's just full of this whole mixture of boulders and
from different places. It isn't just the rock that was here in the seafloor. Maybe some of it got pulled from deep water, maybe some got pulled from shallow. It all got jumbled together and dumped here.
All right, so what could have happened here that would explain something so dramatic?
Well, it had to be a hugely energetic wave in the ocean, a giant tsunami.
If an asteroid 10 kilometers across landed in the sea or at the edge of a continent, it would displace incredible amounts of rock and water, causing tsunamis over 100 meters high. These giant waves would have crossed the sea with the speed of a jet, ripping up the seafloor, moving tons of sediment. As that debris came to rest in what today is the Brazos River Basin, it would have mixed with ejecta falling from the sky. Okay, so now we're here in Texas. Is this making you think that you're a little closer to the crater in Texas than you might be in Italy, for example?
Exactly, because we can see the products of the impact mixed into this tsunami deposit. So we're getting warm.
Hildebrand was hot on the trail of every new piece of evidence. Next stop, Haiti, where he investigated a report of volcanic rocks. As he suspected, they were actually ejecta, full of shocked minerals and spherules. They also contained melted rock called tektites, another telltale sign. More evidence that a strike had occurred somewhere around the Gulf of Mexico. But somewhere wasn't precise enough. Ironically, a key clue discovered by another geologist had long been overlooked. Years before, Glenn Penfield had hunted for oil on the Yucatan Peninsula in Mexico. From the air, Penfield saw nothing unusual. But his instruments measured differences in gravitational fields and revealed the features of a giant buried crater. It was Hildebrand who eventually followed up on Penfield's work. Rock samples from the area Penfield identified showed all the signs of a high-energy impact.
And it was full of shock quartz, too. So this evidence finally convinced everybody that indeed there was a big crater buried on the Yucatan Peninsula.
After years of speculation, the crater had finally been found. It was named the Chicxulub crater, after a village built over its center. The discovery of the Chicxulub crater was the ultimate evidence of the asteroid impact, and it tied together all of the clues that had been gathered over the previous decade. The shock quartz, the tektites, the spherules that had fallen across the Earth. Moreover, the crater was the same age as the KT boundary, and it was the size predicted by Luis Alvarez. We now knew for certain what happened on that horrible day. The asteroid crater had finally been found, but important questions remained. Which species were wiped out at the end of the Mesozoic? Which survived, and why? The search for those answers led to the Badlands of the Dakotas and Montana in the Hell Creek Formation. Its eroding buttes hold fossils of plants and animals that lived during the last million years of the Cretaceous and beyond. When paleontologist Kirk Johnson discovered this KT boundary with its telltale spherules, he found the dividing line between two vastly different worlds.
You're looking at a ball of glass that used to be the bedrock in Chicxulub, Mexico.
Kurt, how important was it to find the KT boundary up here in North Dakota?
If you can put your finger on the boundary like you can right here, what that means is you can ask the very simple question, how was life before the impact different from life after the impact? All you gotta do is look for the fossils below and compare them with the fossils above. And that's what we've done here for the last 30 years.
This arid landscape was once a wet, lush forest. Crack open some rocks, and you'll find the leaves of plants and trees that flourished here over 65 million years ago.
Yes, look at that.
You can even tell what insects ate them.
Holy cow. And see, there's 2 different kinds of insect damage on this leaf as well. There's sort of a hole feeding within the leaf, and there's a margin feeding on the edge.
Take a close look at the ground, and you can pick up fossils of small animals that thrived in lakes, rivers, and forests.
So in my hand, I've got evidence of a turtle, fish, crocodile, fish, and mammal. So,
And then there were the dinosaurs. The challenge, connecting their fate to the KT boundary. The clues, their fossilized remains.
this is an ankle bone of a small meat-eating dinosaur. And you find these bones, identify the animal, and pretty soon you start assembling the list of dinosaurs that are present at any given level. And the lower you are in the formation, the older you are, and the higher you are, the younger you are, and the closer to the boundary you are, the more we address the question of how long the dinosaurs survive. So this, just nearby, we found this bone, which is a bone of a much larger meat-eating dinosaur. Same bone. See the size difference?
Right.
And here's the exact same bone. So when you find bones of different species in the same layer, they're living at the same place at the same time.
The work takes a great deal of time and patience.
This is basically how you find a dinosaur. You know, you're walking around, looking in these gullies, and then you spot a piece of bone. You can see it's very porous, and then you know that it had to travel down, force of gravity. You can see the bone trail. Here's a bone, here's a bone. Follow the trail of bone up, and then here you have a shin bone of a duckbill dinosaur, really broken up. And then here's where it would articulate with the knee joint.
Scientists know that 22 types of dinosaurs lived in Hell Creek, including Triceratops, Tyrannosaurs, and this duckbill, some 9 meters or 30 feet long. The more complete the skeleton, the easier it is to reconstruct the past. But discoveries like these are extremely rare.
You walk around, in the Badlands out here, and you'll pick up numerous just chunks of dinosaur, chunkosaurus, that's what we call it. And that's about it. So usually you find piles of bones that aren't articulated. They're not in the correct order. So having the vertebrae in the right order like this is very, very rare. And what makes this specimen even more important is it's articulated and it's pretty close to the KT boundary.
We've now found several specimens that are very close to the boundary. And really what that's showing us is that even if dinosaurs are rare, if you look long enough, you'll find them when they were living on the planet. What we have not found yet is any dinosaur skeleton anywhere in the world above the KT boundary layer.
Scientists now knew what lived here and their ultimate fate. Within 1,000 kilometers of the impact, death came quickly.
If you turn your oven on broil, open the door, put your hand into the glow bar, that's what the dinosaurs felt very soon. And they were probably broiled alive within an hour or so.
For dinosaurs further away, death may have been delayed, but not for long. Soon, vaporized ejecta and smoke from fires filled the air.
And there may have also been a lot of sulfur blown into the atmosphere because the impact site in the Yucatan Peninsula had a lot of sulfur in it. And all of those things were abundant enough to obliterate the sun.
Without light, anything dependent on photosynthesis, on land or in the sea, was vulnerable. As food chains collapsed, giant reptiles still alive died off. The Mesozoic era, the age of dinosaurs, was over. And there were other radical changes. In Kirk Johnson's Denver lab, you can see what happened to plant life. Samples taken from below the KT boundary show a high diversity of pollen grains, stained here in red. But above the boundary, this earlier diversity disappears, reflecting the extinction of 60% of all plant species. Where flowering plants once thrived, ferns took over first. Unlike pollen, fern spores can germinate on a barren landscape, devoid of living plants.
We have a short period of time where there's only ferns. That's the fern spike. But after that, there's about 1 million years of time where we have the low diversity disaster recovery flora. And after that first 1 million years, then things start to pick back up again. We start to see animals coming back into the landscape.
In this new post-impact world, the niche that dinosaurs left was waiting to be filled.
And so the survivors of this on the land were creatures that lived in holes, birds, mice-like creatures, turtles, frogs, things that lived in swamps or rivers or near the seashore.
And compared to dinosaurs, they had the advantage of size. They were small.
Small animals have large population size. Small animals have higher reproduction rates. Now, it's not saying that small animals didn't suffer mass death, but enough survived, and that's the key point.
In that 1 million years of recovery, the small inherited the earth. It was the beginning of the age of mammals. Eventually, larger mammals dominated the land, just as dinosaurs had done before. And among them were primitive primates, whose evolution would lead in a very promising direction, at least for humans.
What the asteroid impact taught us about evolution is that it's not always about survival of the fittest. Sometimes it's about survival of the luckiest. And there's a profound point there for our species. Only after the extinction of the giant reptiles did mammals flourish, including our primate ancestors. Without the asteroid, there'd be no us.
Okay, that's for. Let me just stop the share screen. Okay, discussion.
I had thought, I mean, I knew that sequence of the asteroid collision and then the death of the dinosaurs, but I had actually thought it took a long time for the dinosaurs to die out, like a few million years, as the landscapes changed. But this presentation here has gone back to, I guess, an earlier understanding of mine that it was much, much quicker, like within a lifetime and I think they're saying even less, but like a human lifetime, although there weren't humans.
Yeah.
So that was interesting to me.
Yeah, I think so, because given the death of the plants, then many animals will not survive, because once you don't have the herbivores, the herbivores die, and then the cannibals will also die, and therefore, as told in what interests me is that it's the small animals which survive. It's not the large one. Previously, when the dinosaurs are roaming the space, these small animals are almost pushed to the margin in the holes, in caves, little spaces. But once the big guys are gone, they become bigger. So that is one of the very interesting, I suppose, life cycle. You need a death to allow another species to thrive.
Well, not quite analogous, but is the fact that the progress isn't the right word. The spread out of mankind from Africa has resulted in the demise of the megafauna.
Yeah.
So no mastodons, no picture, and of course, even here in our own continent, my understanding is that the megafauna here died out sort of at the same time as people first began colonizing this area.
Yeah.
In again about 65
65,000 years or more. Yeah. Yeah.
I think in practical terms, the large against the small animals, the large ones, their food supply would dry out first. There wouldn't be enough food for a large animal, but there'd still be plenty for a number of smaller ones to exist.
Yeah, and therefore the small ones survived. And then also explained in the video, the small ones tend to have a shorter life cycle.
Yes.
And we produce more. So their survivability is much better in case of a huge disasters like that. So I have been looking at a very interesting animal. What's that called? A very tiny animal called tadpole, something like that, which is on average about a tenth of a millimeters, very, very small.
Ooh, gee.
But they are great survivors. Now, they can withstand temperature up to 500 degrees Celsius.
Wow.
Well, and also survive at almost 1 degree absolute zero, minus 272 degrees.
Ooh.
They were found in the top of the Himalayas, as well as 6,000 meters deep in the sea. And somebody had took them to space, left them out in the outer space, in vacuum, and then for 12 days, and then take them back, give them some water, and they come alive again. So
Wow.
if a disaster come, the next species probably is that one. Let me see, I can just search that again and then show it to you. I find it amazing. How come?
Yeah.
What's that called? Okay, I can just bear with me a little bit. Okay. Yes, it's called tardigrade. Okay, tardigrade. Let me get the Wikipedia out, and I will share screen to you for you guys to see. Okay. How do I share screen? Here. Come back to here. Share screen. Tardigrade. Which one is the tardigrade? This one. Okay.
So, Albert, do they exist in any form today?
Yeah, they're still alive here today.
Yeah.
Well, if man took them into space, they've got to be around.
Oh, of course, yeah. What a silly question.
Okay, this one. This little creature.
Oh, yeah.
It has 8 feet, probably no eyes, and the mouth is in the lower left corner. That's the mouth. The next picture. When it is hibernating, it looks like this. It becomes a shell, and it can be completely dry. This is the guy who found this wonderful thing. Okay, why seeing human heads? Okay, let's see. After that, yeah.
Do we know how long they've been around, Albert?
I don't know. I haven't. This is a good question. Let's see. They must be along for a long time, because given how they can survive, I think I can.
They would have evolved and be probably different now to what they were a few million years ago.
I don't know, because we need somebody to take some fossils to find them out. Okay, come on. I'm doing a search on YouTube for that one. Tardigrade. Okay. How long is this one? I think I want to see the one from TED.
We're extending JobKeeper until the 28th of March next year and coronavirus supplement income support until the 31st of December 2020, because keeping businesses in business and Australians in jobs helps our economy. Visit australia.gov.au, authorised by the Australian Government, Canberra.
Without water, a human can only survive for about 100 hours. But there's a creature so resilient that it can go without it for decades. This 1 millimeter animal can survive both the hottest and coldest environments on Earth, and can even withstand high levels of radiation. This is the tardigrade, and it's one of the toughest creatures on Earth, even if it does look more like a chubby, 8-legged gummy bear. Most organisms need water to survive. Water allows metabolism to occur, which is the process that drives all the biochemical reactions that take place in cells. But creatures like the tardigrade, also known as the water bear, get around this restriction with a process called anhydrobiosis, from the Greek meaning life without water. And however extraordinary, tardigrades aren't alone. Bacteria, single-celled organisms called archaea, plants, and even other animals can all survive drying up. For many tardigrades, this requires that they go through something called a tun state. They curl up into a ball, pulling their head and 8 legs inside their body, and wait until water returns. It's thought that as water becomes scarce and tardigrades enter their tun state, they start to synthesize special molecules, which fill the tardigrade cells to replace lost water by forming a matrix. Components of the cells that are sensitive to dryness, like DNA, proteins, and membranes, get trapped in this matrix. It's thought that this keeps these molecules locked in position to stop them from unfolding, breaking apart, or fusing together. Once the organism is rehydrated, the matrix dissolves, leaving behind undamaged, functional cells. Beyond dryness, tardigrades can also tolerate other extreme stresses: being frozen, heated up past the boiling point of water, high levels of radiation, and even the vacuum of outer space. This has led to some erroneous speculation that tardigrades are extraterrestrial beings. While that's fun to think about, scientific evidence places their origin firmly on Earth, where they've evolved over time. In fact, this earthly evolution has given rise to over 1,100 known species of tardigrades, and there are probably many others yet to be discovered. And because tardigrades are so hardy, they exist just about everywhere. They live on every continent, including Antarctica. And they're in diverse biomes, including deserts, ice sheets, the sea, fresh water, rainforests, and the highest mountain peaks. But you can find tardigrades in the most ordinary places too, like moss or lichen found in yards, parks, and forests. All you need to find them is a little patience and a microscope. Scientists are now trying to find out whether tardigrades use the tun-stave, their anti-drying technique, to survive other stresses. If we can understand how they and other creatures stabilize their sensitive biological molecules, perhaps we could apply this knowledge to help us stabilize vaccines, or to develop stress-tolerant crops that can cope with Earth's changing climate. And by studying how tardigrades survive prolonged exposure to the vacuum of outer space, scientists can generate clues about the environmental limits of life and how to safeguard astronauts. In the process, tardigrades could even help us answer a critical question: could life survive on planets much less hospitable than our own?
Isn't that interesting?
Yes, Albert. It reminds me of an organism that is supposed to live in Lake Eyre. So if the lake's dry for some years, I think it could be a fish, and it's the egg of a fish that'll lie dormant until water comes, and then the life cycle comes again. The water dries up as it does there in a shallow lake, and then it goes back to an egg. Anyone else heard of that? I don't know. I haven't got any names for it, but I remember learning about it decades ago. Mm. Yeah, but quite interesting. Similar to this. So they're very tough.
Very tough. So if it is so tough, it might have survived millennia. So probably they will be there. I think it's up to the scientists to try to find fossils of them. So we will be really interested in how long ago they survived.
I'm surprised they haven't got a higher profile. I mean, I've never heard of them until now.
Well, we learn something new
sorry,
every day.
Sorry, what's that, Sue? Sorry, what did you say?
We learn something new every day.
Well, yeah, but I'm surprised they haven't got a higher profile.
Yeah. Okay, you can start researching them, and then probably you can tell us more about this tardigrade sometimes later. We give Albert an assignment.
No, well.
Well, anyway.
That's your job, Albert.
Okay. Okay. Any other questions? No. Then we will switch over to the yes, Sam.
Yes, I heard there's one, I think in northern China, which is a golden fish. It's survived for more than a couple hundred years under the frozen.
Sam, could you turn your volume up, please?
Just a couple of years. I think a few months ago I seen that there are some golden fish found in the frozen ponds underneath for 100 years, and then later on when dissolved
The fish come alive.
the ice, and it's just moving again.
Yeah. Well, well. I started looking at this one because in one of these my Chinese Cantonese channel we talk about science, and so some people ask about how can plants or animals survive extreme coldness, and then
And
there's and then they started to notice that there are some salmons, for example, can be frozen in ice, and then once it's unfrozen, then it survived. And then they start looking at the mechanism of these guys, and then eventually this again, like any science activities, they start spotting out, looking at other possibilities, and eventually they lead to this red, what's that called, tardigrade. So well, yes, there are some mechanisms. The main one of the application is of course the freezing of eggs and sperms for future reproduction. So how do you freeze them and how do you keep them alive in a frozen state? Because one of the main question is when ice freeze, it expands.
Yep.
The expansion will break apart your cell, your eggs, your sperm, then you die, because once it break apart, the DNA get broken apart, then it no longer is able to reproduce. So the interesting question is you have to either fill your cell with something which will not expand where it is frozen, or remove all the water out, or make sure that when the water expands, it doesn't when the water are frozen, it doesn't expand. So there's a lot of mechanisms doing that. So it's quite interesting. Maybe
maybe they have a natural antifreeze.
Sorry?
Maybe they have developed an antifreeze, a natural one.
Yeah. Antifreeze, the natural antifreeze using proteins. Yes, Beverly?
Albert, you should recommend to people they read a book by Lawrence called The End of October. And the gist of it, which I'm giving a spoiler alert, is that it's about a pandemic, and it was only published in 2018, so it's very timely. But the gist of it is that the virus came from thawing out mammoths in the tundra, and that locked within them were these viruses from a disease that rampaged the earth 10,000 years ago, and which our bodies, in European bodies, sort of knew a bit about, but not enough to turn on the defense mechanism. But so it's a very interesting hypothesis that this could happen. That mammoths could hold within them, and as they thawed out, release a virus that had weathered the storm and was there to rampage again.
What's the name of the book again?
It's called The End of October.
October, the month.
And the author's surname is Lawrence, Lawrence. It was the ABC's Book of the Month last month.
End of October.
Very timely book to read.
Okay, yes, Lawrence White.
Yes, and he seems to predict quite well how hopelessly the United States would cope with the whole situation and how well China would.
Okay, I'm downloading the book now.
Yes. Just a bit of fun to read it, but in the end, you find out where the virus is tracked down to.
Anyone want to
where
read
its
this?
source is. It's not a Chinese lab or a Russian lab, because the Russians were still the enemies in 2017, 18, Trump hadn't switched to making China our enemy at that stage. Russia was still the enemy until they got something on Trump. So they were still the enemy when the author wrote this book. So they had it escaping from a Russian lab. But in fact, it wasn't from a Russian lab at all.
Okay.
Anyway, just an interesting sideline on a surviving cold.
Yeah, okay. Anyway, thanks for that. And then we will
Thank you.
see
See
you
you next
again
one.
in the next China Today Zoom session.
We'll see you then.
Okay.
Thank you, Albert.
Thank you.
Thank you, Albert.
Thank you. Bye-bye.
Albert?
Yep.
Last week, we got off to change over. I signed on too early. You weren't there. I got something to eat and come back, and then I was locked out.
Okay.
So can you just keep it open a bit longer?
Yeah, okay.
I was there
will
for about
keep it
half
open.
an hour,
Yeah.
then I gave up.
Sorry about that last week.
No, just one of those things.
I wondered why you weren't there, Cyril, because you're normally so...
Yeah.
It told me when with the second one that it was in motion as though I couldn't get into it. I think I was in the waiting room.
I have to... I think I turned off the waiting room, but somehow you come back again. So I will check the waiting room.
Maybe as you go through each week, just check it, please.
Okay.
Yes,
Yeah, I
Albert.
will check it now.
Thank you.
Thank you. See you next.
Okay.
Thank you.
Okay, bye-bye.
See you in a few minutes.
Yep. Okay, let me just